Okay, so we'll go over that one. If anybody else has other questions about them, I'm happy to go over them. So FeO is called what? Well, we know that it is some form of iron, it's iron something oxide, and if we go do the sort of backwards crisscross, we know that there had to be, so we've got FeO. We know that there had to be a positive iron ion and a negative oxygen ion. So if we take our subscripts and back cross, well, that would get us 1 and 1. But there's a problem. Does 1 form a -1 ion? Forms a -2. So we know that this must have been simplified, so this must have been iron 2 oxide. Does that make sense? And those are tricky ones. Anyone where there's been simplification. I think by far the harder ones are where you have something like lead 4 oxide. So lead 4 oxide is PbO2. Well, when you reverse crisscross that, you're like, oh, lead 2 oxygen 1. Sure, but it's lead 4 because it was simplified. So I think those are the toughest ones, honestly. Okay, other questions, comments on stock system, the quiz? Okay. So with that, let's move on. If you could get out that ion reference sheet I gave you yesterday. Okay, so now what we're going to start with is polyatomic ions and compounds made with polyatomic ions. You already know what a polyatomic ion is. Poly means what? More than 2, really. Some people quote it as many, but you know, if you've got more than 2, polymorphous, many-shaped, polytheistic, many gods, polyatomic, many ions. So you've drawn Lewis structures for these. What you have is a group of atoms that are bonded together covalently, like our good old friend nitrate. And I'm not drawing the resonance here, but I'll draw all the little atoms in that I can fit. And that little nitrate travels as a unit. As a whole, it's gained an extra electron. But you're not going to break that up. You're not going to split that up. It is a chunk. It is a unit, and it's called nitrate. So the most common polyatomic ions are your oxyanions. Remember how creative chemists are? Guess what oxyanions have in them? Oxygen. Guess what kind of charge they have? Negative, because they're anions. So an oxyanion is a negative polyatomic ion that's got oxygen. If you look at that middle table where it says common polyatomic ions, you'll notice, let me actually do a picture of this so that I can discuss this as we go. You'll notice that the columns are kind of broken down. I'm going to divide these out for you. So this is all things that have a charge of 1. And up in the top part, you have all of the commonly used polyatomic ions that have a charge of +1. There's only one of them. It's ammonium. There are others, but in terms of ones that we commonly use, that's the only one that we commonly use. Everything down here, if you look, every single one of them has oxygen. Every single one of them has a -1 charge. Those are oxyanions. They have oxygen. They have a negative charge. They're oxyanions. And those are your -1s. And we'll just talk about the organization, then we'll go back and actually talk about some specifics. The second column, gee whiz, is things that have a charge of 2. And again, up here at the top, you have your positive, your cations, your polycations. And notice that neither of those cations has oxygen. So you've got ammonium, which is NH4 1 plus, and dimercury, which is actually two mercury atoms bonded together covalently, and then having lost 2 electrons overall. We don't have a whole lot of positive polyatomics. And then we've got all of these guys are your -2 polyatomics. We've got carbonate and chromate and dichromate. We'll talk about the specifics in a second. The third column, well, it's your 3s. You'll notice that there's nothing up here with a 3+ charge. There are no, and that's not to say, and I am not enough of a chemist to say definitively there is no polyatomic ion with a +3 charge. I don't know, there could be. There are none that are commonly used. There are none that we commonly see. So it's possible one exists. I don't know about it. There are a few common 3- polyatomic ions. Okay? So that's sort of the general layout of the chart. If you want to highlight or color code or anything else for this for yourself, you can. I'm a insane visual learner. I've never felt it necessary because I kind of laid it out for visual learners, since I am one. But if you want to color code, go for it. That's fine. Okay, so let's talk about those endings. Remember how I said that you really had to pay attention to your IDEs? Well, let's talk about why that is. Because if we look over here, let me get rid of that stuff and that stuff. If we look over here, you're going to see that there are 1, 2, 3, 4 different oxy-an ions that are composed of chlorine and oxygen. Zoinks. You got ClO3 1-, ClO2 1-, ClO 1-, and ClO4 1-. And they all have different names. So the temptation is, because you will also notice that we have NO3 1-, NO2 1-. We also have SO4 2-, SO3 2-. And you have to keep those names straight. So the temptation is to go, oh, well, if it's got 3 oxygens, it gets this name. If it's got 2 oxygens, it gets that name. It couldn't possibly be that easy because it just can't. The system is the most common gets the ATE. The most common ion gets ATE. So whatever occurs more often. So and I'll ask you to look at your ion reference, of NO3 1- and NO2 1-. NO3 1-, NO2 1-. Which is more common? Write it down, don't yell it out. We said that the most common gets the ATE. So, first you got to find these on your reference sheet and you've got to name them. Who's got it? Okay. Who's still searching? I got 2 who have it. 3 who have it. 4 who have it. Twitch or something. Cross your eyes, stick out your tongue. Up in your ear, I don't know what. Got it? Okay. So what are you looking at as the clue that it's more common? You're looking at the ATE ending. So what are these called? Nitrate, nitrite. Ooh. So which one's more common? NO3 1-. This is the nitrate ion. It is more common. And we see it more. We see more compounds with nitrate. We see sodium nitrate and potassium nitrate all the time. Sodium nitrate's a fertilizer. Okay. Well, the one that has one less oxygen than the most common gets the ITE ending. That's easy. So for things like nitrate, nitrite, you can see there's most common, there's one less oxygen. For sulfate, sulfite, SO42 minus is sulfate. That's more common. It's got the ATE ending. One less oxygen, SO31 minus, it's the sulfite. In some cases, there are more than two ions that get formed. So let me get rid of all this. If you have one less oxygen than the ITE version, you are hypo with ite. So for the chlorine, because they form four, there's chlorate and chlorite. And those are your, common and one less oxygen than most common. One less oxygen than the chlorite is a hypochlorite, and one more is a perchlorate. Okay? You don't have to worry too much. I don't expect you to memorize those naming conventions. You are going to have this reference sheet on every quiz, every test, all your homework. You're going to be using this reference sheet till the end of the year. You'll have it constantly. It will get dog-eared and worn, and you'll dribble coffee or whatever else on it, and that's good. You're using it. Okay. So, why does this matter so much? Well, let's look at three compounds. NaN, NaNO3, and NaNO2. So, these are just ionic compounds. Just like doing binary ionic compounds, the first kinds of compounds that we talked about, all you're doing is writing the names of the ions, and that gives you the name of the compound. So for this first one, what's the first ion called? Sodium. Yeah, if we were just talking about the ion, we'd call it the sodium ion. When we're naming it in a compound, we drop the word ion. So this is sodium, and what is the, and this would, be Na3N. Nitride. So this would be sodium nitride, because IDE means it's a monoatomic ion. So then, for this one, what's the name of the first ion? It's again, okay, it's sodium. We've got that, Moser, come on. What's the name of the second ion? Now, here's the clue, and here I'll tell you the trap that students fall into. At the beginning of the year, if I ask you, or if I go and ask a bunch of freshman physical science students, people want to go, sodium nitrogen oxide. You start to realize that anytime you have two things together, and you're going to just recognize these very soon. You'll just recognize, oh, NO3, that's nitrate. You have to go look at your ion reference sheet. Look at your common polyatomic ions. What is NO3 called? Nitrate. So this is sodium nitrate. What's the last one? So again, it's got, same first ion, so still sodium. What's NO2? Nitrite. Okay. Very easy, not hard at all. You're going to be using your reference sheet the whole time. You're always going to have that reference sheet with you. The big key for you is recognizing those ions and knowing that anions always come second, cations always come first. So let's practice some more naming, and then we'll do some formula rating. Can I flip? Okay. So if I give you NH4 NH4F. The biggest challenge is really picking apart the polyatomic. Where is the polyatomic in there?
In the beginning.
Yep, it's the NH4. Okay, and what's that polyatomic ion called? Ammonium. This is ammonium fluoride. And we see ammonia paired to all kinds of halogens because, hey, you've got a +1 charge. Hey, you've got a -1 charge. It's marriage made in heaven. So we see ammonium chloride, ammonium bromide, less commonly ammonium iodide. But, okay, that's easy. Good. So let's do another one. Let's do K2SO3. Write down the name. Sulfate, yeah. Sulfite. I have to be careful too. Potassium sulfite. Because we know that that SO3 is the sulfite ion. Do you all get that? Okay. Let's make them a little squirrelier, and then we'll go flip it on its head, and I will give you names, and you give me formulas. So, all right. NH4 2 times CrO4. Ooh. Does everybody and their neighbor have ammonium chromate? Good. Ammonium chromate. These are not hard. You're just finding the chunks and naming them and putting it together. Ooh, should I give you a hard one? I should. Okay. Go. Okay, so we're doing copper. We know copper forms multiple ions, so it's copper something nitrate. If we reverse crisscross, so we know that there was some positive ion here, and we take this, that would give us nitrate with a 1 charge. Is that correct? Yes. Copper with a 2 charge. This is, in fact, copper 2 nitrate. If you just write copper nitrate, it's wrong. Yes?
No, wait.
Let's go ahead and do some formula writing. So let's start off with potassium phosphate. Potassium phosphate. So the first thing, anytime that we are going from names to formulas, write down your ions. So we've got potassium is K1+, phosphate is PO4 3-, and now we're going to put those together with room for a subscript. 3. Now, here's the thing that's a sort of a trick, sort of a sideways trick when you're dealing with polyatomics. You don't have to do this all the time, but you can put that polyatomic ion in parentheses as a reminder that whatever number you have here is going to go outside the parentheses. Now, of course, in this case, it doesn't matter because it's a 1, so we're just writing K3PO4. But what we're really saying is that there are 3 potassium ions for every 1 phosphate ion. We don't normally write the parentheses if the subscript on the polyatomic is 1, but it can be helpful. So I've had students who always write the parentheses even when there is no subscript, and I tell them that is perfectly fine. I will not mark it wrong. If you go and take college chemistry, they will laugh at you and make fun of you. Just don't tell them I was your chemistry teacher, and we're all fine. But if that's what you need to do to stop from making a mistake, do that. By all means. I will not laugh at you or make fun of you. And I can't control what they do when you get to college chemistry. So you're on your own then. Okay, let's look at ammonium oxide. Okay, you wrote down your ions, so you've got ammonium, which is NH4, 1. Hey, practice is on the corner of lab table 1, Polyatomic Ion Practice. I'm here tonight, and I'm willing to stay 5th period. I got somebody talking about stock system. NH4, 1 plus, O2 minus, looks like this. All 3 of them. Yep. I've got them lined up. Boom, boom, boom. Hey, have a wonderful day, folks.
I work.